Question number 5. Calculate the mass of sodium acetate, that's CH3COONA, required to make 500 ml of 0.375 molar aqueous solution. So the molar mass of sodium acetate is given, and that's 82.0245 grams per mole. Alright, so first of all, let's just write down what is given and then go from there. Okay, so here molarity, or rather let's start from the, so first you've been given the volume of the solution is equal to 500 ml. Next, we've been given the molarity of the solution, which is 0.375 molar. Capital M for molarity. And we've also been given molar mass equals to 82.0245 grams per mole. Now we need to calculate what is the mass of sodium acetate. So let's take the formula of molarity. Molarity equals to moles, or rather the number of moles. So moles of, I'll just write number of moles, it's easier. Number of moles of sodium acetate over here divided by volume of the solution. Since it's in milliliters, let's put it in milliliters, and it will be multiplied by 1000. Right, but number of moles of sodium acetate will be equal to the mass of sodium acetate divided by its molar mass. So all we are going to be doing is substituting this over here. So here you don't know the mass, right? We have to calculate the mass of sodium acetate. We'll be dividing it by molar mass. So this will become equal to mass divided by molar mass of sodium acetate whole divided by the volume in milliliters into 1000. Okay, so we've been given the molarity, that is, I'll just erase this place. So we've been given the molarity as 0.375 is equal to mass divided by molar mass. So mass we don't know, so I'm just going to write it as mass divided by molar mass, 82.0245 whole divided by 500 into 1000. Now when we rearrange this, we will get mass of CH3COONA, that is sodium acetate, equals to 500 into 0.375 into 82.0245, and this is whole is divided by 1000. So when this is simplified, we will get a value of 15.38. Okay, so simple simple thing that I'd like to point out here is the units, right? So here it's a 0.375 molar solution. Here this whole thing will be 0.375 and you will be excluding this. So this and this, the units are getting cancelled and you need not worry. And here this is in grams per mole. So all of this cumulatively will get cancelled with each other and then you will be left with the units of mass alone. That's it. And so first we were given the volume, molarity and the molar mass. Mass divided by molar mass will give us the number of moles. So we just applied that part over here and then we were able to calculate the mass of CH3COO Na. And this, the detailed explanation of molarity is in the video of the various ways of expressing concentration. Question number 6. Calculate the concentration of nitric acid in moles per liter in a sample which has the density of 1.41 grams per ml and mass percentage of nitric acid is 69%. So similar to the previous question, this question also deals with the topic of ways of expressing concentration in a solution. So here we've been given first of all, we've been asked about the concentration in moles per liter. So moles per liter, the unit of molarity is moles per liter. So we need to calculate the molarity of the sample. So we need to find out the molarity. Now, we have been given the density, which is 1.41 grams per ml, and we've also been given the mass percentage of HNO3, that's nitric acid, 69%. Now when we are given the mass percentage of something, here it means that 69 grams of nitric acid is present in 100 grams of the solution. So we have gotten the mass of the solution. So mass of the solution is 100 grams. So density equals to mass by volume. And when we want to find out the volume will be equal to, so volume of the solution equals to mass of the solution divided by its density. So this is 1.41 grams per ml, 100 grams divided by 1.41 grams per ml. Grams will get cancelled, leaving us with ml behind. We get 70.92 ml. Okay, now molarity. I'm so sorry. Molarity equals to number of moles of the solute divided by volume, and since we have volume in ml over here, we'll have to multiply it by 1000, multiply it with 1000, because here you have the molarity, the volume in ml, we need to multiply the whole equation with 1000, because molarity is number of moles in 1 liter of the solution. So we need to calculate the number of moles of nitric acid. Here we know that the mass of nitric acid is 69 grams. So number of moles of HNO3 will be equal to the mass divided by its molar mass, which is 63 grams per mole. So we leave it as 69 by 63 because we anyway have to solve for molarity. So we will just have to substitute this over here. So here you will get 69 divided by 63 whole divided by the volume in ml, which is 70.92 into 1000. When this is simplified, we will get the value as 15.44 molar. So here all we're doing is we've been given the density and the mass percentage. So from mass percentage we were able to calculate the mass of the solute as well as the mass of the solution. And density is mass by volume, so volume would be equal to the mass divided by the density, which is already given, and then from there we were able to calculate the number of moles, and then we substituted all of this in the formula for molarity. Question number 7. How much copper can be obtained from 100 grams of copper sulfate and copper's atomic mass is 63.5 AMU, or atomic mass units. So 1 mole of copper sulfate has 1 mole of copper. Okay, so 1 mole of copper sulfate has 1 mole of copper, which means basically 1 mole is nothing but 1 gram atom. Okay, so molar mass of copper sulfate is equal to basically mass of copper 63.5 plus 32 plus 4 into 16, and this totals up to become 159.5 grams of copper. Oh sorry, 159.5 grams. The reason I'm using grams over here is because we're talking about molar mass, whose SI unit is grams per mole, but since we are only going to be considering 1 mole, so 1 mole of copper sulfate has 159.5 grams of 1 mole of copper sulfate, the mass, the gram molecular mass. So 159.5 grams of copper sulfate has 63.5 grams of copper. Then 100 grams of copper sulfate will have how much of copper? So how much copper can we obtain from that? So this is equal to, mass of copper obtained from 100 grams of copper sulfate is equal to 63.5 divided by 159.5 into 100. When this is simplified, we will get 39.81 grams. So when we speak about 1 mole of that particular substance is equal to the gram atomic mass or the gram molecular mass based on what we are talking about. So 1 mole of copper sulfate has 1 mole of copper in it. So 1 molar mass of copper sulfate was calculated 159.5 grams per mole. So in 1 mole you have 159.5 grams of copper sulfate, and in that the amount of copper is 63.5 because we are considering the gram atomic mass. So 100 grams equals to how much? Basically we just cross multiplied and obtained the answer. Question number 9. Question number 8 was already solved along with question number 3. There we had to calculate the molecular formula of the oxide of iron. So question number 9. Calculate the atomic mass, that is the average atomic mass of chlorine using the following data. So we've been given the two isotopes of chlorine and their respective natural abundances along with the molar mass. So first let's consider and calculate the mass of 100 atoms of chlorine, because we've been given the natural abundance of these two, and I figure it's easier for detailed explanation about the average atomic mass and the atomic mass itself. Do check out the video on atomic and molecular mass. So first let's calculate the mass of 100 atoms of chlorine. So this is equal to 75.77 into 34.9689 plus 24.23 into 36.9659. So here we're just multiplying the natural abundance, percentage natural abundance, with the molar mass. So this will give us the value of for the mass of 100 atoms of chlorine. So this is equal to 2649.59 plus these two, when they are multiplied, you get a value of 895.68. So when these two are added, the since we are only considering 2 points after the decimal, because this has only 2, so when we add it up, we get 3545.27. Now this is the mass of 100 atoms of chlorine. Mass of 1 atom of chlorine will be equal to 3545.27, yes, divided by 100. So when we divide, the decimal point moves to the left. So you get 35.4527, but we only want 2 points after the decimal point. So you get, or I think we can just deduct it by 1 point. So you will get approximately 35.453. So we just rounded it off because it's above 5 we've written. So basically we've first calculated the mass of 100 atoms of chlorine by using the natural abundance multiplied with the molar mass, and then we calculated the mass of 1 atom by simply dividing the mass which was obtained by 100.